Presenting. Yes, getting acquainted with PySpark.
Here we go. All
Yeah.
right.
Before you start, there is more people coming. Guys, put yourself on mute and do the form that you see on top, so Jonathan can paste himself for us. Thank you,
Yeah.
Jonathan. Take it away.
All right. Just gonna put my speaker notes. There we go. All right. So, hi everyone. I'm Jonathan Rioux. I'm a data scientist, data engineer, depending on what time of the day you're asking, but always a data enthusiast. I work in insurance for many years because there's a lot of data there. I've done forecasting for approximately a decade. Now I'm the head of data science for EPAM Canada. I'll talk a little bit more about EPAM in a few minutes. I'm also the author of PySpark in Action, which I'm going to talk pretty much all night tonight. And I really like Spark, but I really like Python. So kind of a good mix. You're going to see how fantastic PySpark is as a tool. I would use it for everything. I mean, if it could cook dinner, we'd probably use it for that. Before we start, a little bit of self-promotion. So the kind folks at Manning today are, my book is the deal of the day. So if you are interested in buying the book, it is 50% out if you use the code DOTD062520. For those who are more on the Java side, so there's also some love for you. My colleague, Jean-Georges Perrin, just recently finished the excellent Spark in Action, which really tackles Spark in Java from a data engineering perspective. And for those working with Pandas, there's also the excellent Pandas in Action that's available. But my book first. I'll paste the code into, there you go. So a little bit about EPAM. I'm going to try to do this under 1 minute. There's a couple of EPAMers as well in the meetup tonight. If you have any questions, we're probably the biggest company you've never heard of. We're a 40,000 people company, basically a lot of engineers. So we do software consultancy, we do data consultancy, we do design. We do work with a lot of clients globally. There's a very good chance that if you're able to reach the internet, you are touching code that EPAM wrote. So there's a couple of openings in Toronto. We also have a program, and this is the reason why I took the screenshot. EPAM is a company that's remote by design. We have workers from all across the globe. Toronto is one of the hot market where we have a higher than usual concentration, but there are some positions on our website that are listed as remote by design, which means that you can work from anywhere. If you have any questions about EPAM and some of the amazingly cool stuff that we do, you can go on the website, or you can also just ask questions at the end. So the goals of the presentation, first of all, is to pace myself. I want to share my love of PySpark, basically explain why I fell in love about using that software, explain where PySpark shines, so where is it amazing at, introduce the Python and Spark interrupt, so basically how does Python and Spark work, get you hopefully excited about using PySpark, and then just give a quick overview of basically what's offered on the cloud. So Spark is for large-scale data processing, and one of the reasons why I think this is appropriate for serverless TO is, you know, it's a complicated piece of software. Not everybody wants to manage their cloud. We at EPAM had major project where we use manage Spark with some cloud providers. So just want to talk a little bit about our experience and why you should try it. So what I expect from you, basically, you know, a little bit of Python, or a little bit of Java, or a little bit of Scala, or a little bit of SQL. basically, you're going to see that Spark speaks multiple language. I'm stronger in Python, which explains why talking about PySpark, but a lot of the concepts that we're going to be talking tonight are applicable in any language. Also, I am super open to ask questions. This won't be a super deep talk. We have just 1 hour. But at the same time, if you have any specific questions or if you need help, we are available. So what is Spark? So if you go on the website, the first thing that you look is you see Spark is a unified analytics engine for large-scale data processing, which, translated doesn't mean a whole lot much. So why is it different than the other offering? Why are you what is cool about Spark? So my definition that I use is Spark can be thought of a data factory. So basically, you have multiple elements in your factory that you mostly program like a cohesive computer. And this is kind of the fantastic thing where a lot of distributed computing or a lot of offering on a big data space, maybe less so over the past couple of years, but when Spark was launched, it was kind of the first time that you were able to literally start playing around with data that was like petabyte scale and just run it like it was a single entity. So when I saw that at first, it took me kind of a long time to get why Spark was so good, because when you're working with data that fits in memory, Pandas is really good, and there's other stuff that you can use. But the moment that it gets big, you don't realize how much trouble you're getting into until you use a framework that kind of gets your back. So under the hood, we're just gonna get a good quick overview, and I'm not going to spend too much time. The goal is really to look at the code and see why PySpark is so fun. But just to give you a little bit of context, basically you are 100% on the left-hand side. So where the driver program is, this is legitimately where you stand and you don't move from there. You send your instructions, and they get propagated across multiple computers in a mostly transparent fashion. If you do your job right and you have enough capacity on your cluster, you'll never hear Spark mention anything about server, which is kind of the goal. Oops, I lost my focus. So this is me trying to draw. So the way that I see it is legitimately like, if you think about data processing, it's literally raw material comes in and something comes out. And the why it's a factory, it's basically because it is this data analytics is disorganized as basically just a big factory with a bunch of table and people. So think of the table as your computer and think about your people as the cores of your computer. So there's one person, which is called a cluster manager, who coordinates the work of all the factory floor, and the data goes inside the factory and it moves from table to table. Depending on what you're asking, your data might travel a lot, which makes your whole pipeline less efficient, or your goal as a data processor, which includes machine learning, which includes data engineering, which even includes high-level analytics, is to make the data travel as little as possible within the factory so that insight can come out faster. And this is what we're going to look a little bit tonight. How does Spark makes it so efficient? Am I going too fast?
Nope.
No. Okay. Cool. All right. If there's anything, you can just type like slow down. So, why is PySpark cool? So, a couple of elements that I think are really interesting, and I'm gonna differentiate PySpark from Pandas. I'm going to differentiate PySpark from MATLAB. I'm going to differentiate PySpark from SQL. Basically, a lot of the other tools or a lot of the meta languages that are used for data and analytics. So the first thing that's pretty awesome, I learned SQL. I think anybody over the age of 25 learned SQL. PySpark uses the same vocabulary as SQL. So a select's a select, a where's a where, a group by is a group by, and a count's a count. So if you take it back, you're able to see it's extremely clear what your query is going to be doing. And this is legitimate like Spark code that people would write. I didn't try to dumb it down. It's a simple query, I'll give you that, but it's like it looks as anything that I would do in a given day if I had a table that looked like this. On top of that, what's uber cool about this is you can legitimately use SQL. So Spark, PySpark, and all the Spark ecosystem will allow you to use SQL code within your program. So basically, you pass your SQL as a string, make sure that the table is registered. We're going to talk about this a little bit later. So if you have body of code that is in SQL, your transition period to make it work on Spark is 0 seconds. So it's extremely fantastic because you are able to port all of your previous code base to Spark, let it run, and then as you go along, you can iteratively improve your code. For a lot of people in the industry, like this is legitimately a game changer. The data manipulation, machine learning as well, they're using what we call a Fluent API, which I'm a big fan of. This is a code snippet from my book. I basically kind of summarize. It basically gives you the words from a text. So we're just going to go line by line and basically do an English translation. And you're going to realize that, sorry, everything makes a tremendous amount of sense. So we read a text file. We split the column called value. And we use the space as a separator. And the column that's resulting, we call it line. So we alias it. Then we explode our line column. So each element within the line. So if you have more than one words, each element becomes its own record. And we call this word. We lowercase each word using lower. We extract the first group of lowercase letter from each word, so using a regular expression. We filter where each word is not the empty string. We group by word, and we count. So Python overall is usually very English-like. When I started learning pandas, for instance, I found it quite confusing to remember, is it lock or iLock, or what do you need to do, and what are the different functions in order to shape your data. The fact that PySpark used SQL and very English name, it makes for larger code. It's more verbose, but it's almost self-documenting, which I really think helps when you are writing data pipeline. There is a crisis in the data science and the data engineering world where there's a plethora of tools and people are migrating super fast from one to the other, and they don't have time to finish their analysis. Anything that can improve documentation is incredible in my book. Scala, Spark is in Scala. So Scala is a beautiful language that is not for the faint of heart. It's a language that's pretty bulky. There's a lot to tackle at once. But one of the things that the developers of Spark did is they created those amazing bindings. So you can program in Spark in Java, you can use Python, you can use R, you can use SQL. And Microsoft I know a couple of months ago even released .NET bindings for Spark. So if you're using Spark on Azure, you can use C# and F# to code against Spark. So think of Spark really as a platform, and pick your language of choice. It doesn't have to be Python. I just find that the Python API, first of all, is very mature, and Python, the language, is really quick to be productive. All right, so we'll get into a little bit of code. I wanted to do a live demo, but they always kind of mess up. So I copied and pasted all of the code here, and I'll try to go relatively slowly. So for tonight, one of the things that we're going to use, I picked a random data source, which is the National Oceanic and Atmospheric Administration. For those who recognize the window, I'm using BigQuery as a data source. It's just very convenient. The data is already clean, it's already available, it's well documented. So they have a lot going on using that product. And you know, as far as Google's concerned, it's kind of the poster child of their serverless analytics. So it was just a good way to kind of combine two excellent products. So in order to get started, this is usually the first little bit of code that you're going to write in order to start your Spark program. So the first thing that you're going to do is you're going to import Spark. So the same way that when you do pandas or any other library, you import pandas as PD, scikit-learn as sklearn. So from the PySpark perspective, you import what's called the Spark session. The Spark session is basically kind of the controller that's going to give you access to the cluster and basically take care of sending all of your instructions so they can be distributed. Second thing that I've done is I instantiate, that's a mouthful, my Spark session. I call it Spark. And I use basically a builder object, and I pass a configuration. So for tonight, for the example, because the data is in BigQuery, Google provides a BigQuery connector to Spark. It works on any Spark installation. So the code that I've run, I've used Dataproc. I've also used EMR, and I use it locally because sometimes I don't feel like spending money to do exploration. So we create our Spark session. The library is basically something they're going to get out of Maven, if I'm not mistaken. It's a Java library, but you don't have to touch Java code. So yeah, and then we create it. So after that, you're going to see a little bit of text. Spark is by default pretty chatty. It's telling you what it's doing, but I'm just going to skip that for tonight. Now we're going to read some data. So I do a little bit of imports at the top. Basically, the first one is reduce from functools. So for those who are comfortable with Python or any other language that implements some functional construct, it basically allows you to repeat the same operation over a list. I'm not going to spend too much time, but basically what I'm doing is I am reading with that piece of code. I'm reading every table for the NOAA data set from 2010 to 2020. So a couple of things that's relatively interesting is the data frame. If you think of how PySpark represents data is within a data frame, it is a regular Python object. So the fact that Spark is a Scala library doesn't change anything. PySpark puts the data structure that's being used in Spark as first-class objects. So they have methods. You can apply Python constructions. So in this case, if you translate it into iterative code, it's basically a for loop that appends every table from 2010 to 2020. So regular Python, none of your knowledge is gone. And this applies to any other language that you would code Spark in. Spark specializes in big data. So for those who use Pandas, or for those who use Excel, for those who use SQL, maybe less SQL, but you're often used to have the data front and center. You always have like a copy of the data. You type, let's say, GSOD, which is the name of my data frame. In Pandas, you would see the data. In Spark, your data is across multiple computers. So showing the data is actually not that advisable. So what you're going to want to do is start relying very, very much on the schema. So what I use for that is there's a very handy dandy method that's called print schema. And basically what it gives you is it gives you the name and it gives you the type of the column. And this is, in conjunction with, I'll show some data on the next slide, but this gives you already a tremendous amount of information about what you can and cannot do with your data. So in a given day, I must type print schema at least 40 to 50 times. I have zero memory, and I rely on schema to remind me, okay, what's the column name, what it is, and I have a pen and a paper to be able to go quickly. So it's a little bit of a different strategy, but this is basically what you're going to get from a lot of big data processing tools. So Spark's not alone in this, but my biggest advice there is learn to love the schema. It's a really, really good tool. Yeah. So now I'm just going to show some data. I've selected 5 columns, so station, year, month, day, and temperature, and I'm showing 5 records. In PySpark, you need to specify the number of records that you're going to want to show. The default is 20. One of the good reasons for that is Spark can scale to hundreds of billions of records, and it takes a lot of time just to print them. So most of the time you don't want to see everything. So if you have a small table and you want to see everything, I usually put I just type on my keyboard as many numbers as I can. But what you're going to see is you're going to see that it's printing that in beautiful ASCII table. I'm a command line guy, not a big fan of using Jupyter notebooks of some other kind of fancy thing. So I kind of grew to love that representation, but Spark also offers some very good Jupyter binding if that's what floats your boat. So the question that it warrants is basically what exactly happened in order to be able to do that operation. So we did select and then we showed, and we asked to show 5 records. What did Spark do in order to give us those 5 records? How do you orchestrate that behind the scene with multiple machines? And this is one of the key factors. You don't have to worry about it for 95% of the time, but for those extra 5% where you actually want to diagnose and you want to improve the performance of your algorithm, that becomes quite useful. I usually show, when I'm doing an in-person training, I show the Spark UI, but it really doesn't reproduce well in charts. So what I did instead is I basically made a diagram that summarized the Spark UI. So what we see there is all of the operations are getting translated into a node that's basically going to get executed. So for that specific element is, the reduce that we've done with the read and read and read and read and union everything. You can see at the top that we're reading 10 BigQuery tables, so GSOD 2010 to 2019. Then we union them all together, and then we do one last thing, which is called a collect remit, which is basically I'm going to send just so to print, I'm just going to send you 5 records because this is all you ask. So by being mindful of what you're actually asking from the Spark, from PySpark, you can actually speed up a lot of operations. If I were, for instance, to print 100,000 records or a million records, well, Spark would work for a longer period of time. So on my machine, basically downloading all the data from BigQuery, getting it on my my MacBook, and printing it to get 5 records, it takes approximately 3 seconds. So it's really fast, and you're able to explore quite a lot until you're ready to send kind of a full-blown job. So overall, one of the things to understand about Spark, and this is a big source of confusion for people who are coming from small data frameworks, is that what you write is not exactly what's going to get executed, because you're working with multiple computers, because you're working with data that are growing beyond what can be managed with memory. Spark actually takes your operation, whether they're written in Python, Scala, Java, R, SQL, .NET, Julia, and they're going to make it go through a 6-stage process. They're building what they call a logical plan that gets refined multiple times based on some rules about what Spark knows about your data. Where's the data located? What are you trying to do? They're going to change the order of operations. It will never make it will never transform your code so you get something that you didn't ask for, but they're going to re-optimize to minimize the amount of work that's going to happen, and then you're going to get physical plans, which is a list of operations that's going to get performed. So basically, node number 1, you're going to do this, this, and this. Node number 2, you're going to do this, this, and this. Node number 74, you're going to do this, this, and this. And then it applies on the data. If you're using the command line to interact with Spark, you're actually going to see at the bottom kind of a progress bar in ASCII art, which big fan of, which basically tells you how many steps they've decided for a given stage, which is one action on the on your query, and you're going to be able to follow the progress. So it usually gets pretty quickly, unless you have a very underpowered cluster, like if you're working on your own machine. But it gives you a good indication. And then if you need more information, then all of those information are available through the command line or through a web interface that Spark provides for you when you start a job. So I spoke about transformation and actions, which are 2 concepts that are very important when you're working with PySpark or big data framework. Spark won't actually start doing any work. So if you type something and you ask to do like select, group by, sort, join, all that sort of stuff, nothing will happen until you ask something physical with the data. So I gave a good example: select, filter, group by, partition. There's many other, but none of that is actually returning anything to you. Like the output of select is another data frame. You haven't asked to see it. You haven't asked to do anything with it. So writing to disk is an action. Showing something on the screen is an action. Counting the number of records and printing it on the screen is an action. And converting a data frame, a PySpark data frame, to a Pandas data frame is an action. So until you do an action, until there's an action somewhere in your code, Spark is just going to happily take more transformation and just pile them on. And the moment that you have an action, it's going to go through that logical plan process, that physical plan process, and then it's going to start acting. So the penalty of performance that you incur by waiting up until to an action is more than compensated by the fact that, let's say, if you do a big filter, you do a couple of select, some operation, and then you do a big filter and you want to show 5 records, well, Spark's going to know you don't need that many records. So it won't actually try to keep your old data frame. It's just going to drop records as you're going along. So it allows you to really pay, quote unquote, in terms of time, for what you're actually wanting. So this is a big surprise, because sometimes, like, one of the first questions that I get from people who start with Spark is, show took 7 seconds, but write's been running for an hour. Well, you have 5 records into your show, but you're trying to write 74 billion records on a hard drive, a single hard drive, and that might be why it's taking some time. Everybody's doing good so far? Ready for something a little bit more complex? So a couple of things here. This is pretty massive bunch of code for a presentation, but I'm going to walk you through it pretty quickly. Oh, there we go. This one doesn't have any lights. So import the function that PySpark uses. So basically, a lot of the average, min, max, count, etc. They need to hide somewhere. So Spark puts them in a module called PySpark.sql.function. And I'm reading a station data frame from BigQuery again, just to be able to tie the name of the station, because they provide just numbers in the GSOD tables. So if you look at the order of operations, I've put it at the bottom, but basically what I do in order is I read, join, where, group by, I average and count, I do another where, I order by, and I show. So there's those 8 operations that I'm telling them in order, because that's how I logically think. I could have reordered them differently. It would have made the same impact, but this is how I naturally think, and this is how I naturally displayed it. On the next slide, you're going to be able, I put that at the top over here, so the read, join, where, group by, etc. This is the physical plan that was selected. So if you look at this, you can see that it's not exactly what I asked. So a couple of things that happens is, first of all, the filter happens before the join. So Spark was smart enough to realize that, hey, you're actually removing the null values, so the countries that are null. What I'm going to do is I'm going to go on the station table, look at all the countries that are null, map that to station, send the list of null station that you need to remove from your big table, so that your join's not going to be as big. So your Spark is actually smart enough to do a pre-exchange of information that is going to minimize the amount of data that's going to get joined. And this is absolutely, when you get to think about it, for a big data processing framework, this is really cool. Like, I didn't have to say anything to Spark. Just a parenthesis for those who are curious. This only works with Spark 3.0, which was released a couple of weeks ago. This has been in beta for quite some time. But it's one of the big advantage of using. It's also one of the big advantage of staying current with your version. If you're using Spark 2 point something, Amazon through AWS Glue offers something similar, or you can use Databricks if you want to have access to advanced version, but you're stuck on 2.4. After that, so we get the filter with the broadcast exchange, which is pretty cool by itself. If you look where the 2 arrows are getting down, there's a broadcast hash join. So the join that I gave was actually specialized. It specialized the join, and a broadcast hash join. I don't want to go into too much detail, but it's an optimized join where basically, let's say I have 10 machines. I have a big table and a small table. What Spark's going to say is, instead of trying to find the match of the keys and move some data around over the computer, it's just going to make a copy of the small table and send it to every node on my cluster so that the hash join can be faster. So this is a strategy that gets implemented automatically. If your table is under 10 megabytes, you can force it. But you know, in my table, I didn't have to do anything. Spark was smart enough to be able to say, that's going to make your job faster. I'm just going to do it. You're welcome. After that, there's a project function. So because of the group by that is happening, Spark realized that a couple of steps later, it only needs couple of columns. So the projection is the equivalent of a select. And basically it removes all of the columns that I do not need in order to take my my answer. So this is a very good way to free memory and enable faster operations. And it basically removes that dead data. And then the last step that is a little bit funny that we didn't mention explicitly is exchange, which is just basically, you're going to hear that a lot, or you're going to read that a lot in the PySpark literature. It's called a shuffle, which is basically Spark saying, I'm going to reorder the data. So if we think of our factory, it's people throwing data from one table to the other. So you're just, because there's a group by that happens, so the hash aggregate is a group by, you have to make sure that all of the data for a same key is on as little nodes as possible so that it can be efficient. So that exchange do that. So hash aggregate, we filter again, and we take ordered and project. So the plan here is relatively easy to read, but it gives you a lot of insight about what exactly happened. And when the job doesn't work so fast, you are able to refer to that physical plan that is available for every query you're running and answer a ton of questions. So I found this one pretty telling. It's a good example of what you can see. It's not a complicated query. I've seen plans with hundreds of nodes, but I found it to be pretty cool and telling. So for those who prefer using SQL, Spark is going to keep kind of the equivalent of a metastore for data. So a couple of things that you have to make sure is you have to register your table. You do create temp view, which is a method available on the data frame. You give it a name that you want to refer to it in SQL. So I was amazingly creative. I just called them the same name. And then you're able to use the SQL code directly. So that's how I would do it. My SQL is not as strong as it used to be. So if there's anybody who wants to judge me on my code, go ahead. And another thing that you can do is you can also blend both of them. So Spark.SQL returns a data frame. There's nothing preventing you from doing the select from the table if you're not a fan of the Spark select, the PySpark select. Sometimes I feel just very lazy. SQL comes naturally to me. I just write a part of it in SQL and then I continue in Python, and then I get back to it. It's a pretty good luxury to be able to do that. I end up doing it quite often, and it doesn't make your code looks especially ugly. Like, it's very clear about what you're doing. You're doing a SQL query that returns a table, filter country not null, filter more than 60 value. You order by the average temperature that was computed into the SQL, and you show 5 records. So really fun thing that basically, like, you know, that old grumpy DBA in your team can use Spark and not be horrified by the fact that all the data scientists are using Python and ruining his life. Now, I think I have time. Yes. I just want to talk a little bit about the Python and Spark interop. So everything that we've done so far is appropriate in any language. So there's some difference in syntax. You know, Java is going to be is going to look like Java code, Scala is going to look like Scala code, R is going to look like R code, but all of the operations, select, where, all of that is available in any flavor of Spark. So I totally encourage you, if you have a favorite language that is not Python, try Spark in that language. I don't think you're going to be displeased. But Python has a couple of niceties that is really, really cool. And I just want to give kind of a good introduction. This is something I cover extensively in my book because I found that the material online is just terrible. So if you get to think about the data frame, so the data frame is how Spark represents data, column, rows. It can also represent JSON, images, but it really, internally, you don't get to see them that much. But when you scratch the surface, you can see that there's partitions under. So one partition can be on, let's say partition 1 can be on node 1, partition 2 and 3 can be on node 2, partition 4 can be on node 7, for instance. If you squint and you take some time to kind of push a little bit, you could say, like, yeah, so those partitions that are in memory, like they're basically pandas data frames. So like it's not that far-fetched to think about it. And as a matter of fact, starting in PySpark 2.3, which was released approximately 2 years ago, and it was really improved over the past few months. PySpark, Pandas, and a bunch of open source projects, especially related to data, decided to kind of join force into an in-memory representation for data. I'm not going to go too much into the detail, but the logo that you see on the top is Arrow. So if you do a research on Apache Arrow online, you're going to be able to see much more detail. But what it does is it permits the transformation from a PySpark data frame to multiple Pandas data frame according to certain rules very, very quickly. So there is a lot less loss in performance than trying to apply Python code over a data frame row by row, for instance. And I want to show a little bit what it looks like. So for those who are not entirely familiar with Python, I apologize. We're going to do a couple of, we're going to go pretty quickly over some Pandas code. Basically, I'm importing Pandas as PD, and I'm importing types as T. So just like functions were available in PySpark.sql.function, the type of a column. So what does the column contains as a value? It's available on PySpark.sql.types, and I imported with it with capital T. In order to use my UDF as my function, as a user-defined function, which is how PySpark represents function that you created as a user and you're promoting to a data frame. You use a decorator, which is basically just an annotation that you put on top of your function. And the annotation is pandas UDF. I specified that the return value is going to be a double, so T double type. And then my function is basically, I took the temperature and I go from Fahrenheit to Celsius. The data is in Fahrenheit. My editor at Manning is from California. So I was joking with her that Canada is, we cook in Fahrenheit, but the rest of the temperatures are in Celsius. I have no idea what like 350 is in Celsius, but I have no idea what 40 is in Fahrenheit. So Canada. So a couple of things that are interesting here. Spark, starting with version 3.0 that was released a couple of weeks ago, won't actually require you to specify what type of function are you doing. So there's multiple ways you can work with user-defined function. Now, Spark is intelligent enough looking at the type of the function. So if you look at inside, I have F to C. Degrees is a pandas series, and it returns a pandas series. That gives enough information to Spark to implement and optimize how the function is going to be done. So in order to get my series of Fahrenheit to Celsius, I do -32 times 5 divided by 7. And then I am able to unit test my function, because it's not because it's a UDF that I have to use Spark to test it. My function, the original function, is still available on under a func method, so I'm still able to use it like any other regular function. So it makes your code really easy to test, and you don't lose anything. You're still able to use PyTest. You're still able to do unit tests, validate that your code's working well. So you have no excuse for not testing your code. Now, if I want to apply it, I just use it as a function. So I create a column using the with column method that's called temperature_C, and I apply my function on temperature. And as you can see at the bottom, my temperature, so 37.2 is apparently 2.88, etc. In Celsius. And it works really quickly. So for those who've used Python UDF in PySpark from version 2.3 all the way up to 2.4, everybody was telling you, big loss of performance, no good, don't use them. It's not the case with Pandas UDF. They're actually quite nimble, and you're able to optimize them. And that's because of the rapid serialization between PySpark and Pandas that is unlocked by Apache Arrow. This is done. Now, what I'm going to do is I'm going to do a little bit of a more complicated function. So this one takes a data frame and returns a data frame. So I basically, I'm not going to go over the code, but basically what it does, it kind of normalize in a very crude way. So I subtract the min and I divide by max minus min over a given period of time. So basically, I have a function that works on a data frame and returns a data frame. So if I'm able to give instruction to PySpark, I want the data frames to be split like this, and I want you to apply the function on all the data frames separately and then recombine them in a single data frame. That's exactly what a group map UDF is going to do. So basically, what I provide is I give Spark a little bit of help. I tell him exactly what my schema is going to look like. For those who are a fan of SQL, Spark's going to accept the schema in DDL language, data definition language. So I have 6 column, 4 string, 2 double. Here are their names, and I basically use the same syntax if I were to do a group by. So I group by my data frame by station, year, and month. And for each month, I normalize the temperature. So if you look at the bottom, basically for the month of 2010, for the station 8268, for the minimum temperature was 87.4 and the maximum temperature was 89.6 because of the normalization that happened. I see the 0, I see the 1. Done. So this makes it really, really cool because basically you don't necessarily, the creator of Spark didn't necessarily think of all the use case for your function. So you don't have to say, well, if it's not available as a function, I have to like start doing some gymnastic like I used to do, or find a very convoluted way. If you have a function that works in Python, in Pandas, that's using Pandas data frame, you're comfortable using Pandas data frame, you can promote it to PySpark like this. So again, this is, there you go. So basically, what happens here, if you get to think about it, the data frame is multiple partition that gets converted through Arrow in a Pandas data frame, which then get transformed using Pandas and Python to a new data frame that Arrow is going to reserialize back into the native representation of Spark, which then Spark's just going to take a hold of that new memory and call it its new data frame. So really you know, if you get to think about it, like in approximately 20 lines of code, we've implemented something that if you were to try to do it from scratch would be mind-boggling. And this to me is like, just with that, it was enough for me to like fall in love completely with PySpark. But I'm not done yet. So you're not limited library-wise. So if you install the library on all the nodes of the cluster, you're able to use them. So I'm doing some poor man's machine learning. I'm basically computing the rate of change of temperature. So to see, is the temperature across the month increasing or decreasing? So I take the data, so I have the day and the temperature as a series, and basically I assign X to my day. I assign Y to my temperature. I fit a linear regression and I take the coefficient. Like, I'm not going to win any awards for that model, but it was a quick and dirty way to get the actual rate of change without too much fuss. And basically what I'm mentioning over here is that I take two series and I return a float. So that's pretty much it. And then if I get to apply it, I do my GSOD, I group by station, year, and month, and then I do an aggregate where I call my rate of change temperature function. I pass my two columns as a parameter, alias the thing, and then I show the results. Boom. So you're able to really, really quickly implement. And you know, this kind of function opens the possibility for simple, seamless, distributed machine learning. So if you have, let's say you want to do grid search in scikit-learn, and you have access to a Spark cluster, well, there's nothing preventing you from basically multiplying your data frame in batches. Let's say you have 50 nodes, create 50 copies of your data frame, and then basically implement part of the grid search with the parameters that you want and just let it rip. And you don't have to worry about it. No change in code, no change in what you would be doing otherwise. Just pass it as a UDF. Call the group by on, let's say, an artificial key that you're going to have created, and then you can go for coffee. So, you know, this was kind of the eye-opener moment for me, where, you know, it's always good to have something that you're familiar with, and you know, manipulating data is kind of cool, but you know, at the end of the day, as a data scientist, you want to bring insights, and you want to do that faster in a more reliable way. So the fact that PySpark is really like well integrated into a Python library makes your code easy to test, easy to understand, and you follow the same convention as other Python developer. But at the same time, you have a powerful model that you can interact with. And if you're working with data engineer in the backend whose Java is their language of choice, you don't have to fight. They can do their pipeline in Java, promote it as a jar, and you can even import the function that they're going to make available for you using the Python syntax. Maybe a couple of things, a couple of random subject. If I haven't convinced you that PySpark is worth your time, if you're not a fan of the syntax, there is a very cool library with an adorable mascot called Koalas, which is basically a Pandas API on Apache Spark. So you are able to use Pandas code on your PySpark data frame. So from the readme.md, this is a good example. If you're comfortable with Pandas, that shouldn't be shocking. But of course, this wouldn't work with regular PySpark. Databricks is offering and open sourcing that library that you can use very easily. Maybe one of the last subject that I want to talk, and realizing that probably was a good thing that I talk fast, is PySpark in the cloud. So Spark is available usually through what we call managed Hadoop. So it usually comes with a lot of battery included. I personally just use Spark most of the time. All three major cloud vendors have an offering. So there's no specific order I don't have a favorite, at least not for the scope of this talk. But on the left, you have GCP. It's called Google Dataproc. AWS has 3 products that are actually quite different. You have Glue on the left, which is their serverless Spark. So basically, they map specific version of the libraries, and they have a whole ecosystem around it that makes it very easy to do a lot of very boring tasks in the life of the data scientist. So you have a data catalog that I'm a big fan of, and data crawlers that honestly, if you're using AWS, you have to explore this. EMR, which is their equivalent of the Dataproc, so a very manage it as you go. So you get to configure it, your cluster the way you want. And then I'm going to leave the red icon for last because it's both available in AWS and GCP, in Azure, sorry. And on Azure, you have what you call HD Insight, which would be the equivalent of EMR or the equivalent of Google Dataproc. So basically a managed Hadoop on Azure this time. Finally, so the company behind Spark is actually actively developing an ecosystem. A company is called Databricks. At the moment, right now, this week, there is a Spark Plus AI Summit. It is free. If you haven't registered, I really encourage you to go on their website, databricks.com, register for free. There's one last day of talks. It's very interesting. You have people from all around the world talking about the cool stuff they're doing with Spark, the cool stuff they're doing with PySpark. But more about the platform. So Databricks sits on top of AWS and Azure. And basically, they offer facility for better machine learning management. There's MLflow, which is an open source tool that can register your experiments that I really love. They have Delta Lake, which is a way to version your data in a big data environment that's kind of useful when you're data scientist or a data engineer. So there's no bad choice. Per se, they're all really, really good. I would say pick your cloud of choice. If it's GCP, well, you got it. If it's AWS, I recommend starting with a small EMR cluster and play around. If you're on Azure, I would say start with HD Insight if you want to play, and then get yourself familiar with Databricks. It's really, really good. One of the things, so like maybe to finish, like I know it's serverless TO. When I started talking with Daniel, I was like, it doesn't make sense, like serverless Spark. And then by reviewing some of the offers, like I tend to be very, I like to spend time configuring my cluster and looking at like my memory footprint and all that sort of stuff. But all of the offering that we've seen so far, they scale with you. So you're able to specify what you want, how you want it. It's going to automate the configuration of your cluster, which makes it really fantastic because, basically like managing one machine and keeping it secure and productive is already hard enough. What if you have a 50 node cluster that's trying to talk to one another? It's just bad. A couple of advantages of using in the cloud. It's remarkably cost effective. When you get to think of it, like EC2 instances, compute engine, and Azure VM are really cheap. And managed Spark just add like a menial cost on top of it, so you can get started pretty quickly. I spent, like, I think my monthly budget for Spark when I'm writing the book is approximately like $38 a month, and I'm doing quite a lot of stuff. It scales easily. So one of the things that's quite interesting is all of the cloud providers are going to feature what's called auto scale. So the more people that gets into your cluster, if you're managing IT for some data scientists, well, you're able to go up and down as you go, and mid-job, you won't have new nodes joining. So if you started a job and you're it's going to take a little bit of time because you have to finish a stage for Spark to realize that there's some new nodes. But it's very convenient if you have more than one person on it. For those who've used like non-serverless Spark on Cloudera or Hortonworks, or those products have a terrible reputation, not because they're not good, but because it's so hard to figure out exactly how you're going to use your cluster. Everybody, like, I've worked my previous company, like I used to wake up at like 2:45 in the morning because I knew nobody was on the cluster. Like, that's not a way to live. And then some simplified maintenance. Because I want to make some enemies, I'm also going to put three things that I do not like about serverless Spark. From my experience, people tend to be extremely cocky and realize that, oh my God, so much power. So really important to put some boundaries. Ask me how I know. I got on my first day at EPAB, we were working with a client and they decided that they were spinning a 400 machine cluster. And then complaining, like, why is their cloud budget 20,000 for a team of 4? This is how it happens. The pricing model can be confusing. This is mostly for like the completely managed. I'm not a big fan of people calling like, it's going to be like that much money per DBUs or like compute unit or that sort of stuff. Like, at the end of the day, we know it's a server. You want to be able to control a little bit of memory that there is. And I found that most offering, especially on the managed sides, are very anemic. You know, it's even if you're working with a Spark cluster when you want to distribute, the less machine you have to do your computation and the bigger they are, the faster it's going to be because network is always slower. And then one of the last thing, I'm not going to name any vendor, but take some time to get familiar with your documentation. So if you start investing some time and you want to be, like, let's say, familiar with one specific cloud provider, I found the documentation to be extremely uneven. Like, there are some product that I listed on the previous slide that I am not even able to make it work to the way I want. So, you know, documentation matters because no amount of product, as powerful as they can be, is going to make up for the fact that if you're not able to operate it, it's pretty worthless. All right, 1:08. I think I'm in time. I actually think I'm right on time.
Wow.
Thank you, everyone. I hope you had a lot of fun. And I'm going to be there for a little while for some questions.
So this would be the moment for the big applause. So if you can do that, I don't know how virtual. Any questions, guys? So thank you, Jonathan.
I'm seeing come say. So Rayudu, where the upper F coming from? PySpark.sql.function. I just imported it in the previous slide. So basically, like, it's at the top.
Yeah, I saw it in another slide and kept, sorry.
Yeah, and then does PySpark always use pandas underneath? It actually doesn't use pandas until you're asking them to. So it really, you know, if you use pandas UDF, it's going to use pandas. If you don't, it will never use it. And then very interesting, except for the slide with GCP. So one of the things, maybe if you want me to present Alex to the people at AWS, like, I know there's, I think it's Amazon Athena. To be honest, I'm just less comfortable with the product. So maybe throw some credits my way, and I'll be happy to show it next time.
Great presentation, Keating. Great presentation. Very informative.
Cool.
Any other questions, guys? Don't be shy.
What is your suggestion for a beginner to get familiar with Spark? Well, I mean, there's going to be 3 copies of my book. My book's also on sale. I'm like, the reason why I'm writing a book is because I'm a book person. I actually learned to program with Manning. So when I was doing my undergrad, I started working with those books. I find it to be quite fun. In terms of online stuff, if you want to have something a little bit more visual, I found that although it's sponsored by a company, but Databricks offers some great interactive training material. And it's made by the creator of open source Spark. My recommendation would be to really, really focus on the open source component because they're portable, and then scale up into a project. But I use Databricks. Actually, I personally learn reading the source code, reading the API documentation, and spending some time with the Databricks documentation, because I found that the rest of the material is just too, it's either too high level or too low level for my liking. Do you think online certificates such as Coursera, EDX? I think they are, but like, this is a me problem. I don't have the attention span to follow a video class, so I don't use them. But if you're a video person, I think it would be a great way. And then Rayudu, actually, yes, you added, they keep sending free ebooks, 8-step for a developer to learn Apache Spark. But yeah, way to go sending competition my way.
That is just an ebook in the sense it's not a full book, right? It's just giving hints on 10, 20 pages on something like that. So it helps people to just understand. Yeah.
And then Umesh, a couple of mention, love it as the .NET and SQL developer. Yeah, I was actually very surprised. Like, Microsoft did a really, really cool thing with just providing some bindings with .NET. I used F# back in the days. I love the language. I would love for .NET to become kind of a core language offer with Spark, and I think a company like Microsoft would be able to do that. But yeah, I find it fantastic. Like, it doesn't have to be Python all the time. Cool. All right.
Any other question, guys? Anything else? We are ready to do the draw, or is there anything else before we close of Q&A? 1, 2, 3, solve.
There's
So,
another one there. Came in.
Oh, can you please comment on Hive queries versus PySpark queries? So from my experience, I found, and this is really empirical experience, like I didn't analyze my queries extensively, found PySpark to be quite a lot faster. On the other hand, Spark can be configured to use your Hive metastore. So if you have, for this specifically, I only have experience with GCP, but if you have a Hive metastore within GCP and you're spinning up a Dataproc cluster, you can actually connect the two, and then basically your Spark.SQL is going to be able to do select anything from any table that's in your Hive metastore. So this is a good way for you to like read the data one bit and then use the blazing application of Spark. So pretty sure any cloud vendor is having this as well. I think it's kind of a good way to port legacy, legacy. I mean non serverless kind of workflow, but I usually just use Hive to look at the schema of my data before loading it into Spark, and I use Spark for the rest. Glue catalog on AWS is awesome. Yes, it is. It's as metastore. Oh, there we go. Yes, it's also really great. I'm a big fan of. Life would be better if everybody used a catalog properly. So a great kudos there.